Alright, so this is a basic video talking about how Inventor works and helping people that are having trouble with the plane assignment. Now, if you had to make a new file, or a part, or an assembly, etc., you go to the file and you'd press new, because we don't have anything yet. So this is our part file, the IPT. It's basically what you would use if you want to make a small, non-complex, or non-combining piece, maybe like a gear or a screw or a hex shaft, and you would use these IPT files in your assembly, the .iam. Now these .iam files use multiple parts to combine them together and make them into one thing. For your IDW file, this is what you're using for to show specific measurements or different views of your piece so that companies can see them and know what they're getting at before they get sent the file, or to show measurements if the piece is already released to the public or whatever the case is. But this is your engineering notebook page. What's important to note is that this relies on an IPT file. So if you delete the corresponding file, then the page will corrupt. Now this is your presentation file, the IPN. This relies on the assembly file and is basically making an exploded view. Now, if you remember from DDP, an exploded view is pretty much just what they use to show all the parts moving, how they combine, and how to make your assembly or your mechanism. You would depend on these if you're going to show your project to someone for the first time before they get into processing or the specifics. But these are your four main files: your IPN, IDW, IAM, and IPT. You probably will need them for a quiz or test, as Mr. Harb has talked about, or at least foreshadowed. But if you remember in our class, he made us go to projects and then look for or make a new project file, single user, because just yourself, making a project name. I'll just make a folder for example's sake. And then you can go to your storage or your PC or your USB, and you can put it in your USB, or should be here, or you can make a file, a folder, and put it there yourself. Oh, it's right here. Yeah, your sim projects. Of course, I already have mine, so I don't need to do it already. But if you already have your file, you can go onto your USB, find your sim projects file or your other file, and then you should be able to open it. Press this. Yeah. So you have to open with the IPJ, and then it'll be right there. So then you'll press done, and it should be here. So basically what this is it's like a folder that holds all your parts and assemblies, your IPT, IAM, etc. And it's for organization's sake, I guess. But the main point is that you'll use this whenever you need to keep files together for a unit project. It's pretty much just going to help you keep everything organized. So go to templates, English, and we can go to our parts and we can create. And this is how we'll make our 2D or 3D objects. So this 3D model menu shows everything that you need to make a 2D object into a 3D one. So you have your extrude, your evolve, which will pretty much take that 2D object and stretch it. You have your sweep, your loft, your coil, which pretty much do the same thing. Emboss, which will make, like, I guess, a gear shape. Fillet, which is going to round out your sharp edges. Chamfer, which is going to do the same thing but make it flat. Shell, which is going to empty things. thread, which is going to use specific screws and make holes have a slide in them so that way they can have a screw, and your mirror, which is going to take an object and a plane and duplicate it. But that's kind of advanced for what we're doing right now. Anyways, let's open up the plane assignment, download it. So we have your IPT file. So then we can go to, File, Open, and we have our IPT. We can open it. So now we have our basic shape. So this is going to be answering part 1. What it says is to create an angular to planar on edge plane, as shown in A, and to mirror the part using the plane, and then to create 2 planes using 3 points, and it's shown in the image. So basically what he wants you to do is he wants you to go to plane, open the menu, was this, yeah, angle to planar on edge. So then you get to choose what degree you want it to be on, starting from this edge, and we need a 45 degree. You can press OK. And if we look on our other side, we now have a plane. Now that we have this plane, we can take our mirror tool and we can select our features. So we're going to select both the inside and outside, because if you don't, then it's going to just make a rectangle or a square or a box. You won't get the detail that this part is hollowed out. Next, we're going to choose our mirror plane, and then it'll show you a projection of what's going to happen. Press OK, follow through, and now you have the same shape but reflected over a plane. So now we're going to make 2 planes using the 3-point method, as the document says. We're going to open plane, 3 points, and it specifically asks you to use these 3 points. So you can notice that it'll highlight the points for you. 2, 3, and then boom. So now we have 1, do the other. So now we have our duplicated 3-point plane, blah, blah, blah. So now we're going to do this, where we're going to measure the tips. You see, I already have the answer here, but to do this, you can right click and you're going to use the measure tool. And what you're going to do is you're going to click, see, tells you on the document, trying to find this angle. So then what you can do is that you can click this edge, that edge. So then it'll tell you 70.53 degrees. Now the document asks you to choose to the nearest tenth. So since 70.53 is round to 7.5, that's your first answer. Now your second answer. With this shape, we're going to use the fillet and tangent the surface plane tool, as well as the extrude, and we're going to do it like this. So what's asking you is that from this view, let me see if I can, you can also hide your planes by just right clicking it, pressing visibility. Okay. So we have our right, and from this side, we're going to extrude that way, including this little area that you wouldn't really think of, but it's there. And you're going to extrude it up by 1 inch. So you open Inventor, and you can create a new sketch on this side. So now it will open up this view, and you would ideally choose a 3-point rectangle because you can lock onto this point and that. Showing the top view for a rectangle. Alright, so I did this just for the example's sake, sorry. You can notice that I didn't get the point perfectly on the vertex. You can notice that there's some sort of space here. And because of that, your model is going to be off. It's going to show that there's a line here. Not only that, but you can start a new sketch from that place. And this isn't right because we want it to be flush. So what we're going to do, Control Z, and we're going to open back the rectangle tool. This time choose a vertex. Make sure that it's on the line. And then we're going to click the third vertex. So what we're doing is we're finding the length and then its height. So then boom, now we have a rectangle. Extrude it 1 inch. We're not going to use the flipped, the symmetric, or the asymmetric because it's only asking us to pull it out this way. And we have it as join because we're going to add to it. We're not going to subtract or anything. So now we have OK. You can see now that it's flush because it's on the edge. It's on the same level. And you can notice that's the same from the bottom too. So now we open up our fillet tool. And we're going to click the edges that we want to smooth out. Now, it shows us that we're going to push it in with a radius of 0.215. This is what the document wants, but you can change it by just typing it in or changing the settings. Not necessary for the example. Press OK. So now we have our rounded edge. So now we need to create a tangent to surface plane. And the way that we do this is that we open up our plane tool and we'll look for these tangent to surface and parallel to plane / tangent tools, because this allows us to create planes on rounded edges. So we're going to open up tangent to surface and parallel to plane. We're going to click the rounded surface, and we're going to click this one because it's parallel. Pretty sure you can also click this one too, but as long as you just have a plane that's parallel to what we want, and in this case, you want one that's looking like this. Okay. So now that we have this, we can measure the distance from the surface to the new plane. Once again, we're going to right click, measure, we can click the plane, and we can click the edge. This will show us 2.750 inches, and since we're asked to round to the nearest hundredth, our answer is 2.75. So now we have question 3. Create a tangent surface plane through edge / point parallel to the R surface and tangent to the edge. So what this is asking is that we're going to add a new plane on this edge, this line right here. We're going to add a new plane. You can choose plane parallel to plane through point, choose a parallel surface just like the one we just chose, and you can choose a point that's on the line. And doing this will make a plane on that edge. So now that we have the plane, although not through this way, but I'm sure no one knows how to do it, we can now measure. Oops. Going to right click, measure, click the edge, and click this too. So now their answer is 2.625 inches, You can put 2.625 because it says to round the answer to the nearest thousandth. So now for question 4. Create an offset plane a ½ inch above the bottom surface. Create a new sketch. Project the two sides as shown in picture B, and close the loop to form a triangular shape. So you can press done. For convenience sake, we can move these planes into non-visibility so you can show it. You can press plane, offset from plane, click the surface, and you can either drag it up or you can specify 0.5 and then enter. Boom. Now we have our plane. So now that we have this plane, we're going to have to create a new sketch on it. So you can start a sketch and click the plane and its edge, because for some reason clicking the middle doesn't work because there might be things behind it. And we can click this edge for a better view, or it can do that. Okay, so now we can create a line and we can choose this angle, well, this point and this point. Notice how I'll let you click. You can right click to cancel. So now we have our point and should be able to project our geometry. Click the edges, finish, and now we can right click, press measure. We can click three edges because this is our closed loop, and then we can add together 2.475 plus 1.75 plus 1.75, 2.475 plus 1.75 plus 1.75. So now I'll tell you 5.975, and then now that we have our perimeter, 5.975. You could add it together, or you could see the sketch loop is right here. So we can press done. So instead of having to add, we can go back into the sketch, we can edit the sketch, and go to a more suitable angle. God, why is it like doing this? Okay, so now we can go to inspect, and this is where region properties is. We can now select a triangle, press calculate, and it will tell you your area and perimeter here. 5.975 is a perimeter, which is what it's asking for, and it is also what we measured ourselves. So you don't have to use a product, you don't have to use the tool, but it helps. And it's probably quicker than using it by hand, because then you have to measure all 3 edges, then add it together, or if you're stupid like me, open a calculator. Anyways, our last question, using the same thing, create a midplane at the middle of any side. What is the distance from the plane to the side? I took some time, and this is what I think you want for this question. So you can open plane and use the midplane between 2 planes tool. What you're going to do is that I'm just going to use the side for an example. You can click this bottom and the top, and if you'll notice, made a plane in the middle. A midplane, ladies and gentlemen. So what you will do, go to inspect, you can go to measure, go to the plane, go to the top side, and it says 0.125. Okay. I'm not too sure on this myself because it's a different image, and most of the times the image are probably necessary for the context, but running with it, this is the answer. We'll see what happens. Let's see the score, and hooray, 2.625, 0.125. Alright, everyone. So this has been my video talking about Inventor. This is probably going to be like a one-time thing. Thanks for watching. Alright.